So first, I just want to say I appreciate you coming out. 4 o'clock on the last day is usually nap time for conferences, so I appreciate this. Just show of hands, how many people in the room are programmers? All right, good. I was worried I was going to get people who claim to be nothing but database. So, I think maybe 2 years ago, I stumbled across Redis, and I remember making the foolish assumption that Redis was just a simple cache. And so for a while, I just ignored it because I had other caches, and so I didn't need it to do anything. Then I started working for Pivotal, and a lot of the Pivotal customers that I encountered were using Redis as a simple cache, and more and more I ran into scenarios where I needed to use, I needed a key store or I needed a cache that did a bunch of other things. So what I want to go through today is some of the scenarios that, or use cases that I've been through with Redis. I've changed the scenarios a little bit and anonymized things so I don't get sued, but otherwise the domain models are pretty close to the originals. The first one I'm going to talk about is IoT. We saw some of that stuff in the keynote, and I think there's a couple other sessions about running Redis on a Raspberry Pi, things like that. In this situation, there's essentially a cluster of search and rescue drones, as well as sensor devices, and they're sending data back to a central service. And that one's written in Go. The second scenario is what I call a Retroboard. It's basically a tool for agile development teams for doing retrospectives, and so it's essentially virtual sticky notes. And that one's going to be written in Rust. And the third situation is work dispatch or batch processing. I'm sure everybody who has enterprise legacy applications knows what batch processing is and how painful it is. And this one is written in .NET Core. In the room, who identifies as a Go programmer or a gopher? Nobody, almost. Okay. Rust? Fantastic. .NET Core? All right. So my slides won't be a total waste then. So a little bit about me. I've written a few books on .NET, wrote a book on how to do microservices and cloud native development in Go. I've built all kinds of applications for different verticals and industries, some as a consultant, some working full-time for banks, even worked for a trash company once. Good times. As I said, I started using Redis a couple years ago, and the use cases that I've been building on top of it for apps and services have been getting more and more complicated and useful. And as you'll see when I go through these, basically Redis is now a tool that I use for pretty much everything I build. So there's a Microservices and .NET Core book that I wrote that's coming out soon. The early release for it, I think, should be available on Safari next week. I also write fantasy books, if anybody is interested in those. So the first use case was IoT monitor. And like I said, there's a combination of drones and sensors, and they were sending a constant stream of data from the drones to a central service. The sensors were giving regular updates, historical data, so a long list of essentially time series data. And at the time, I wasn't using Redis for time series, so somebody else's problem. The big goal for this project was to support a real-time view of where all the drones were, what their destinations were, how close they were, battery status, flight time information, and all of that was done on a map visualization. And so this diagram, which I lovingly refer to as emojitecture, just shows a really high level of just where everything went. The sensors and the drones were all sending data to a single service. There's a bunch of really technical stuff, edge gateways and things that are all removed from this. That's why I refer to it as emojitecture. And the service was essentially storing everything except the time series historical data on Redis. I don't know if I'm supposed to use the word schema when referring to Redis, but I'm not sure what a better term for it is. But the data structure for storing the information about the drone locations and the sensor data. I had a set that stored the list of all the registered devices, and those were just IDs. Geohashed integers for the device locations. And I had a couple counters for things like the device ID. The device status was just a simple hash map with fields like battery, remaining altitude. There's some other targeting information and so on. But telemetry is where one of my favorite parts of Redis for this particular problem, because each of the different devices had a different set of telemetry. So being able to support the ability to just send an arbitrary list of key value pairs up to the server for storage and retrieval later was invaluable. And then the device registration, in the simplified version of this, I only have two types, drones or sensors, but I had, in the production version of this, there were drones, cameras, sensors, switches, all sorts of other devices that were responsible for this. So when I would receive a device registration, essentially it was just increasing an ID and doing a hash map set. And when a drone would send a new location, it just did a hash map set on the status and then a geo add. One of the early versions of this didn't use Redis's geolocation queries. I don't remember when that showed up, but I was very angry when I found out I had done everything the hard way and realized that Redis had all this stuff in it. And then telemetry was, like I said, just a big pile of name value pairs being sent from, everything from a wall-mounted switch to drones in flight. To query for the application, very simple stuff. An HGetAll on the device to get the individual device information. Another getAll for the status of a device. For this particular use case, the operators had to be able to click a device and immediately see how much remaining battery it had, and it was very important to be able to get the current altitude of the drones. Funny side note, rapid changes in temperature and air pressure fool altitude sensors. So I lost a staggering number of drones to temperature changes alone. So altitude monitoring is fun and why I have no hair. Geodist was, like I said, I did this all the hard way. I had code that did all the annoying calculations based on the shape of the Earth and things like that, and then realized Redis did it for me. So in this particular query, it's essentially getting the distance between device ID 150 and its target in miles. Some of the other, once I found out I could do this with these queries, there were some other really interesting things that I could do, like discover nearby devices and sensors. And I also had sensors that were detecting the drones without talking back to the server. So being able to figure out where those sensors were was also pretty important. And then GeoPause just queries the current location of the device. And then finally, there's just another get all for the hash map for a device's telemetry. Some of the information that was stored there was temperature, air pressure, which was usually wrong, things like that. So the code for this is, like I said, it's been faked and anonymized and simplified so that most of the stuff is just focused around querying Redis. But the code is sitting in GitHub, it's written in Go. The connection to Redis is done through a command called dial, which for the one Go person in the room is a fairly idiomatic Go pattern. And like I said, since there's very few people in the room that write Go code, I'll just kind of skim over this. But essentially, the programming library for this is just a wrapper around the basic Redis CLI commands. And you can see, well, I guess I can't, I don't have a cursor, but yeah, one of the advantages for this particular library is that it lets me take an arbitrary dictionary and feed it straight to a hash map set, which ended up being an extremely fast operation, rather than me having to try and serialize all the properties one at a time. So the other one that I built cost me far less money and insurance bills from damaging other people's property with drones. Was a retrospective board for agile teams, and the basic premise of this was just to use Redis as a NoSQL store for backing a simple application. And it was an app that supported, it had users, retrospective board. Each board had a number of sticky notes on it, and for each one of the notes, there were comments and upvotes. If somebody knows what I should be calling this stuff instead of a schema, please let me know. I think they'll kick me out if I use the wrong terms. So I had a set called users, which just had the list of users in the app. A set of sticky notes, which just contained the IDs. And then a list, or a set that had the list of users that had upvoted a particular sticky note. And, you know, again, because it's a set, everything is unique, so it automatically took care of users trying to game the system by upvoting twice. Okay. And a set for comments, a couple of ID counters, and then I had JSON entities for the user, board, sticky note, and comment. And it's pretty, this application is pretty straightforward. Just every time I create a new board, add to the identity, or to the ID, add the board to the set. And I'm going to have to try and see if this is any more fun to play with the JSON plugin or the JSON module. Right now, it's just storing everything as raw strings. And so I'm incurring the serialization penalty in the code. If a user wants to upvote something, it's just an add to a set. And querying is pretty simple too. Just use S-members to get the list of boards. Z-range to get the sticky notes in chronological order. Sticky notes is a sorted set. S-card to get the cardinality, so just quickly count the number of upvotes. And then again, S-members to get the list of comments for a particular sticky note. This is all written in Rust. The code's in GitHub. There's the Rust equivalent of node modules or packages is called a crate, and there's a crate available for Redis. You create a Redis connection, and very similar to the Go library, if you know how to use the CLI, you automatically know how to use this library. You just feed it the CLI commands and the parameters, and it'll do what you expect it to do. This is the Rust code for, I think that there were 0 hands for Rust users, so that's encouraging. Like I said, basically it's just a wrapper around the CLI commands, so even if you can't read Rust, you can see sort of where it's going with that. It's just got a wrapper around the various commands. The work dispatch or enterprise batch management solution was built for a very, very large insurance company that every so often would re-rate all of its insurance policies on the order of 6 or 7 million policies at a shot. And so they needed to fan out this work. And the original version, they literally had 15 physical machines that were running all the time, idle 29 days out of the month. And then on the last day of the month, those machines would hit 100% CPU. So clearly they benefited from some cloud native architecture. So with the batch management system, we had a mix of long-term and transient. So it's kind of a mix of the first two solutions. So there was some clear cache usage as well as using it for a NoSQL store. It supported multiple concurrent processes for reading and writing. So we had literally thousands of worker processes doing the individual work. And as work was completed or failed, we used the Redis pub/sub for notification. So this was basically split into batches and work items. A batch was just a hash map with the details on the batch. Obviously, I don't have all the real details here, but you sort of get the idea. And then a set or a list for the work items. And then each work item had a status and all of the parameters. So right here it's input 1, input 2, but you can imagine like all of the policy data would have been on the work item. So to create a batch, just do an HM set, and then for each item in the batch, we added an individual batch item with all of the details that belong to it. And then as worker processes would re-rate policies or do whatever it is you wanted to do in async batch processing, it would write the results and then publish on a pub/sub channel. And in this case, the data on the channel is the batch ID and the work item ID. And I used 2 different channels here, one for success, one for failure. To query the batch, it's just an hgetAll. S members to list the work items that belong to a particular batch. And the subscriber will just subscribe to the succeed and the fail channels in order to get status updates. So the work dispatch code is also sitting in GitHub. The library I use to talk to Redis is stackexchange.redis. You connect to it through an object called a connection multiplexer, and you obtain a reference to an iDatabase. The main difference between this library and the other two is this one doesn't actually let you type in the specific Redis CLI command. It has wrappers, method names that are similar but not identical. So this one was it wasn't difficult to use, but if I had to pick one, this one was the highest friction. So since most of the room raised their hands for .NET, this should look fairly similar or fairly familiar to you. In this case, we're just incrementing the ID for the batch. We create an object called a hash entry and send it to Redis. It's all pretty straightforward, and I did a benchmark on these. The Rust one obviously came in fastest, but the .NET Core one was surprisingly fast. So, like I said, I'm a programmer, not a database expert, so I probably did all sorts of things that are making everyone upset. I didn't do things the idiomatic Redis way, but in most of these situations, I just needed to get something done, so Redis was the tool that fit the bill. A couple of the things that I took away from this is my original impression that Redis is just a simple cache was completely wrong. And I've so far been pretty pleased that I was wrong about that. With Redis, the data modeling is by access and usage patterns and not according to rules for database normalization. So it was a refreshing change to be able to think about how I needed to write my data, how fast I needed to write it, how I was going to query it, and have that model be exactly what I use Redis for, rather than trying to translate my usage into some god-awful pile of third normal form tables. We used PubSub and Redis for one of these, but it could have been used for a number of other situations that came up. We just had other solutions in place, but the ability to have PubSub sitting inside Redis was invaluable. As I said, I did all the geospatial stuff the hard way the first time and would never do that again. And being able to query not just GPS positions, but to be able to do slightly more interesting things like detect all of the devices or all of the other locations that are within some radius of some target point, and have that come back in microseconds time is pretty amazing. The CLI commands, basically, once I was able to use the CLI, I was able to use Redis from any programming language. Even the .NET library that changed the names of the functions a little bit, basically I used the CLI to pretend to be my app until I got the usage pattern right, and I was able to experiment in the CLI. And then from there, it was just a matter of, in some cases, literally copying and pasting the CLI commands into my code. Probably the most difficult decision I had when modeling the data was deciding between whether I was going to store all of my data in one key as a big giant JSON string, or whether I was going to use a hash map. And you know, not being a Redis expert, I probably made the wrong decision a couple of times here, but the usage pattern I settled on was that if I needed to change a couple of the keys or a couple of the object properties without changing all of the other data, then I went for a hash map. Whereas if the read-write pattern was always all or nothing, then I found it easier just to use the JSON string. Using scores on sorted sets. At first I didn't really appreciate how powerful this feature is, but being able to choose an arbitrary score and then use that for whatever my app needs it for was pretty powerful. Obviously it comes in handy when you want to use Z-range to get a time-ordered list and use timestamps, but there's another situation where I've used the score to actually expire individual members in a set. And like I said, I modeled all of my application behavior in the CLI before building anything, and it saved me an enormous amount of time. So I had some code demos, and I had planned on skimming through some of the Go and Rust source code, but I wasn't sure if anybody actually wanted to see that. So I can go and I can dive into more detail on some of the code, or we can just skip right to Q&A. Raise your hand if you want to see more details on the code. All right. Okay, so if you want more details on the code, just come on up and ask a question. Otherwise, I'll just take regular questions. I'm sorry, I didn't hear. The Go. Yep. So let's see. So the Go code is basically, it looks pretty similar to the stuff that I was showing on the slide. I just used the dial method or the dial function to connect. And then this is incrementing the device ID. And in this case, I'm using a struct to hold all of the information that I want to add to a hash map. And then I use the add flat function, which basically just runs through this structure and uses the Redis name tag on these to choose the hash key name. And basically the connection.do is roughly equivalent to executing this command on the Redis CLI. So like I said, with the Go and the Rust libraries, if you know how to use the CLI, it becomes really easy to talk to Redis with these languages. So yeah, this one is registering a device. This one was updating the device status. That's really where all the work is that and the connection.do. And telemetry was a little bit different in that the telemetry readings is a hash map of string to float, and we just used the add flat function to take that entire dictionary and dump it into the hash map. Yep, I think one of the microphones is here, but I'm sorry, I can't hear you. Okay. So for those who didn't hear, the question is about the .NET libraries, and I believe you wanted to know about the clustering support. The only .NET library that I used was the Stack Exchange one. I believe there's another one that's available that doesn't work with .NET Core. So one of my requirements is that I did not want to touch a Windows machine to do any of this code. So I used .NET Core, which for those that don't know is C#, .NET on a finally cross-platform, completely open source framework. And for this one, it's all the stack exchange.redis. And when you do connect here, the connection multiplexer object is responsible for choosing your cluster client options. So you can give it a list of IP addresses or just one. In my case, for these relatively simple samples, I'm just connecting to localhost. But actually, here's another interesting one. If you use localhost here, this application will crash. If you use any DNS hostname at all, that application will crash. There's some steamy pile of garbage down deep in the .NET source code that when they ported it, makes the wrong Linux call or the wrong Unix kernel call and won't resolve host names. So that was annoying, but it's a known issue in the source code, and theoretically, since it's open source, somebody's going to fix it, but it doesn't appear to be fixed yet. And worse is, side note, is there's some other libraries that build on top of this stack exchange.redis library, and those all break when you use host names instead of IP addresses. So you know what rolls downhill. Sorry, did that answer your question? Or?
So we were using Microsoft for client as well. I wanted to know the differences between this. This one actually gives cluster support, but Microsoft doesn't give cluster support. So I was wondering, should we really use this one with the Redis Labs Enterprise? Because that already gives a cluster support.
So I'm not sure what you mean by cluster support, because this is just a client. So if you're just talking about cluster awareness, this client is cluster aware. One thing that I would highly recommend, whether you're using .NET or regardless of what language you're using, is if you're putting this stuff in the cloud, never ever leave your connections open. I can't even count the number of times AWS has, for 1 millisecond, just shifted a connection or blown a socket out from underneath and everything dies. So just as a safety measure, I always clean up the connections right after I'm done talking to the database. I had that same problem with Mongo.
Thanks.
Any other questions? All right. Oh. Well, the wrappers around the Redis API, and when you pass the commands to them, it's essentially calling the same commands that you would call in the Redis CLI, because the Redis CLI is a consumer of the Redis API. Yes, by a factor of 10.
That's specific to the Redis communication, or was that the overall application? And if it's the latter, how would you compare across these applications?
Well, when I was doing the benchmarking, it was just reading and writing data in a loop. And I had a sample client that read and wrote data in Rust, in Go, and in .NET Core, and it was the same couple 100,000 keys. And the Rust one was just remarkably faster, and I think that's largely due to the fact that Rust has no garbage collector. All right. Well, thanks very much.